friends, welcome back to my channel. I am Vishnu Yadav and I am with a new topic in the subject network analysis, and the topic is superposition theorem. Introduction. The superposition theorem is a powerful tool in the linear circuit analysis. It simplifies the circuit. It states that the total voltage or current in a linear circuit is the algebraic sum of initial source. Understanding this theorem is analyzing circuits with multiple sources. Principle of the superposition theorem. The principle of the superposition theorem states that in a linear circuit containing multiple sources, the effect of each source can be analyzed separately by turning off all other sources. The contribution of each source can be determined individually. This allows for a systematic and efficient analysis of complex circuits. Let us go through the superposition theorem and let us verify the superposition theorem. First, the statement of the superposition theorem. It states that in any linear bilateral multi-source network, the response in any branch is equal to algebraic sum of the response obtained by considering each source acting separately by making all the other sources set equal to 0. The voltage sources are made 0 by short circuiting it, and the current source is made 0 by open circuiting. The voltage source is made 0 by short circuiting and the current source made 0 by open circuiting. Consider the network shown below. Let's apply KVL, means loop analysis, for the loop 1. Apply KVL to loop 1. Z1 into I1 plus Z2 of I1 minus I2 equals to voltage V, and we simplify the circuit, and the last equation is I1 equals to V plus I Z2 divided by Z1 plus Z2. And for the loop 2, let us apply KVL for loop 2. We know that already in the circuit I equals to I2, Ix equals to I1 minus I2, V plus I Z2 divided by Z1 plus Z2 minus I, and Z2I minus Z1I minus Z2I. Z2I get cancels, and the final equation is Ix equals to V minus Z1I divided by Z1 plus Z2. Let us verify the superposition theorem. To apply superposition theorem, consider any one source. We have to make one voltage source or the current source by short circuiting or the open circuiting. Let us consider the voltage source and set current source to 0. We are considering the voltage source first, and when we consider the voltage source, the current source will be short circuited or the open circuited. I1 equals to V by Z1 plus Z2. In case 2, consider the current source and make the voltage source 0 by short circuiting. Now we can connect now we should consider the current source, not the voltage source, and let us make the voltage source short circuit. Using the current division rule, I double dash equals to Z1 by Z2 plus Z1 plus Z2 whole minus of I. According to the superposition theorem, actually current Ix equals to I1. According to the superposition theorem, is actual current equals to Ix equals to I dash plus I double dash. Final equation, Ix equals to V minus Z1I divided by Z1 plus Z2. Equation 3 and 2 as same ends. The superposition theorem is proved. Now let us do one problem on the superposition theorem. Let us consider this circuit. In case 1, we should take the 2 volts and make 4 volts short circuiting and take it as 0. Now in first case we should take 2 volts and make 4 volts as 0 as the given here. For apply we should apply KVL for loop 1. The equation is 14i1 minus 12i2 equals to 2, and again for loop 2 the equation is minus 12i1 plus 15i2 minus 2i3 equals to 0. Next we should apply for loop 3 minus 2i2 plus 5i3 equals to 0. The final currents are I1 equals to 0.518 amperes, I2 equals to 0.437 amperes, I3 equals to 0.175 amperes. Now we have to find I dash. I dash equals to I2 minus I3. I2 minus I3 equals to 0.26 amperes. In case 2, we have to make 4 volts. We have to take the 4 volts and make 2 volts as open circuit, short circuit. So by applying KVL for loop 1 and 2, we will get the I1 equals to 0.350 amperes, I2 equals to minus 0.408 amperes, I3 equals to minus 0.963 amperes. Now I double dash equals to I2 minus I3. I double dash equals to 0.555 amperes. This is the superposition theorem. Thank you friends. Thank you for watching till last.